In this video, we will discuss events involving OR. Here is one example. If one number is randomly selected from the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, find the probability of each of the following events. First, the number is odd or a multiple of 4. A number can't be both odd and a multiple of 4. We call such events mutually exclusive. There are two numbers that are multiples of 4, 4 and 8, and 5 that are odd, 1, 3, 5, 7, and 9. There are a total of 7 values that satisfy the criteria. So the probability that an odd number or a multiple of 4 is chosen is 7 out of 10. Now, find the probability that the number chosen is odd or a multiple of 3. There are 5 odd numbers still, 1, 3, 5, 7, and 9, and 3 multiples of 3, 3, 6, and 9. However, 2 of the multiples of 3, 3 and 9, are also odd. So there are only 6 different values that satisfy the criteria. So the probability that the number chosen is odd or a multiple of 3 is 6/10 or 3/5. Here are the addition rules of probability for the event A or B. If A and B are any two events, then the following holds. The probability of A or B equals P of A plus P of B minus P of A and B. That is the probability of event A plus the probability of event B minus the probability of items that satisfy both A and B. If A and B are mutually exclusive events, then the following holds. P of A or B is P of A plus P of B. So the probability of A plus the probability of B. Note, if A and B are mutually exclusive, P of A and B is 0 because they do not have any elements in common. So the first rule applies in all cases. For example, if a single card is drawn from a standard 52 card deck, what is the probability that it will be a spade or a red card? First, note that spade and red card are mutually exclusive events, as spades are black. The probability of drawing a spade is 13 out of 52, or 1/4. The probability of drawing a red card, that is a heart or a diamond, is 26 out of 52, which is 1/2. So the probability of a spade or a red card is 1/4 plus 1/2, which is 3/4. Another example. Amy plans to spend from 1 to 6 hours on her homework. If X represents the number of hours to be spent on a given night, then the probabilities of the various values of X, rounded to the nearest hour, are shown in this table. Here are our values, 1, 2, 3, 4, 5, 6, and the probabilities 0.05, 0.10, 0.20, 0.40, 0.10, and 0.15. Find the probability that Amy will work on her homework for A, fewer than 3 hours. So if we're looking at fewer than 3 hours, that's 1 or 2 hours. So the probability of fewer than 3 is the probability of 1 or 2, which is the probability of 1 plus the probability of 2. So that's 0.05 plus 0.10, which is 0.15. These are all mutually exclusive events that we're dealing with in this problem. The probability that she will work on her homework for more than 2 hours. The probability of more than 2 is equal to the probability of 3 or 4 or 5 or 6. That's the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. We look up those probability values and they add up to 0.85 or 85%. The probability that she will spend more than 1 hour but no more than 5 hours. So that's the probability that the number X that is chosen is greater than 1 but less than or equal to 5. So that's the probability of 2 or 3 or 4 or 5. And that adds up to 0.80 or 80%. Finally, the probability that she works fewer than 5 hours on her homework. Well, the probability that she works fewer than 5 hours is 1 minus the probability that she doesn't work fewer than 5 hours. So the probability that she works 5 or 6 hours. So 1 minus the probability of 5 or 6 is 1 minus the probability of 5 plus the probability of 6. And when we add those probabilities together, we get 0.25. 1 minus 0.25 is 0.75, or 75% chance that she'll work less than 5 hours. The table in the previous problem lists all possible time intervals, so the corresponding probabilities add to 1. The time spent on homework here is an example of a random variable. It is random because we cannot predict which of its possible values will occur. A listing like that table, which shows all possible values along with the probabilities that those values will occur, is called a probability distribution for that random variable. Probability distributions will be further explored later. One more example. Find the probability that a single card drawn from a standard 52-card deck will be a diamond or a face card. First, these are not mutually exclusive events. The Jack, King, and Queen of diamonds belong to both events. So we let D denote the event that a diamond is drawn. F denote the event that a face card is drawn. So the probability of D or F is the probability of D plus the probability of F minus the probability of D or F. That should be the probability of D and F. So that gives us 13 out of 52. That's the number of diamonds, 13. Plus 12 out of 52, the number of face cards, minus 3 out of 52, the number of diamonds that are face cards. That's 22 over 52, which is 11 over 26.